Okay. So last week we started talking about the Pythagorean theorem. Okay. So the Pythagorean theorem can be used on a right triangle. So who can tell me what the parts are to a right triangle? What's this? That's our right angle. So this is our right angle. Okay, what's this? The hypotenuse. Good. This is our hypotenuse. And how do we know where the hypotenuse is? Okay, it's going to be the largest. That's true. What else? If you start at your right angle and go through the triangle to the opposite side, you are going to end up at your hypotenuse. Okay, and then these, what are these called? The legs. Good. And your legs are drawn off of your right angle. And what letter did we use for the hypotenuse? When we're talking about the Pythagorean theorem, what letter did we use? C. And what were the other two? A and B. Did it matter which was which? No. So this was A and this is B. So then what does the Pythagorean theorem look like? A squared plus B squared equals C squared. Or I said leg squared plus leg squared equals the hypotenuse squared. Whichever way you want to think about it. So in triangle number 1, there's our right angle. Which side is the hypotenuse? Which side is our hypotenuse? The opposite side. What number is with it? Nothing, right? So through the triangle to the opposite side is our hypotenuse. And there's nothing. And what letter did we use for the hypotenuse? C. What are the other two sides? A and B. Those are the legs. Does it matter which is which? No. Okay. So we'll call this one A and this one B. And what did the Pythagorean theorem say again? What did it tell us was true? A squared plus B squared is C squared. Okay, so what is A? So 15 squared plus, what was B? 8 squared equals C squared. So 15 squared plus 8 squared gives us 289. So C squared is 289. Are we done? No, why not? What do we want? We want the square root of it. We want just C, right? So we can take the square root of both sides. What does the square root mean? It's asking what number times itself gives you 289. Okay, so we push the blue key, x squared, and we can type in 289, and we get 17. We get 17. Okay, what is 17 times 17? 289. Okay, so when we take the square root of 289, we're wondering what number times itself is going to give us 289. So, 17. What does that represent? 17 is C, right? What is that? What do these numbers out here mean? 15 and 8. Want the phones up. What do 15 and 8 mean? Do we know, or are we just not going to talk? So, well, what does the 8 mean? It's how many units. It's how long it is, right? So 17 means that side C is 17 units long. Okay. So number 2. How do I identify the right angle? Okay, where your two legs meet, what always has to be there if it's going to be a right triangle? That 90-degree angle, that box, always has to be there. This says this is a right angle. Otherwise, you can't make the assumption. You can't decide that it is. What's all the way across on the opposite side of the triangle? That's our hypotenuse. And what letter do we use for our hypotenuse? C. And what are these two sides called? the legs. Okay. Which one is A and which one is B? Is 9 A or B? Doesn't matter. Let's call it A. We'll call this one B. So how do we find the hypotenuse of a right triangle? What's your formula? What's the formula to find the hypotenuse of a right triangle? A squared plus B squared equals C squared. All right, so Doma, what's A? 9. So 9 squared plus Miriam, what's B? 5 plus 5 squared equals C squared. All right, so Devea, what is 9 squared? 81. And Derek, what's 5 squared? 25 equals C squared. Okay. Dulce, what's 81 plus 25? 106. All right. So, Edward, we know 106 equals C squared, but we're looking for C. What do we do? We've done all that. So now we're right here. Find the square root. You can take the square root of both sides. So we get C, and what is the square root of 106? 10.3. Okay, so the length of C is 10.3 units long. Okay. So, I'm going to pause this for a second. Are we still writing? Go ahead, you can write. 10.3? I want you to take a minute and I want you to find the distance between H and K. I want you to find how far apart they are. So let's see. Laura and Carlos, I want you to pair up, okay? And then Yenny and Sophia. So Yenny, go ahead and move up next to Sophia. Dilma, Marion, Edward, Luce, and food together. Anna, Andrea, the two of you. Andre. Okay. So I want you to take a minute with your partner. Okay. And I want you to explain to your partner how you found the distance between 2 points. Okay, H and K. I want it to be in English. Okay. And you can start it with, I found the distance between points H and K by. Okay. And then you can explain how you did it. Okay, there's a lot of different ways to do it. Okay, Carlos, go ahead and pull a chair over with Laura. And Edward, how about you move back one? There are a lot of ways to find the distance. You can translate it. You can translate it. Look it up in your phone and translate it. If you know what it is in Spanish. But I'm not sure how to say it in English. It's just practice. How did you do it? Don't move on yet. Okay. So, Marion. No. You're okay. How did you find the distance? What did you do? You counted, right? Good. So, Dulce, what did you get when you counted? 6. So you counted 1, 2, 3, 4. So you said 1, 2, 3, 4, 5, 6. So you counted the spaces in between? Yeah. Tick marks in between. Anybody get anything different than 6? Nobody got anything different than 6? What'd you get? You got what? 7. How did you get 7? What did you do that was different? Say again? Oh, you subtracted. Okay, so we have counting and we have subtracting. Okay. So when we're counting, we have to be a little careful because you don't want to just count. Hi. We don't want to just count the tick marks. You want to count the hops. So you're starting at 2, and we hop to 3, 4, 5, 6, 7, 8, 9. So how many hops do we have? 1, 2, 3, 4, 5, 6, 7 hops. Okay, so when you're counting, you want to count the hops. Like you're a bunny. Okay, so the distance between H and K is 7. Okay, Edward, you also subtracted. What did you do?
I just subtracted 9 plus 2.
So 9 minus 2?
I got 7.
So 9 minus 2 gives you 7 as well. Okay, so do both methods work? Yeah. How come you did 9 minus 7 and not 9 minus 2 and not 2 minus 9? Thank you. Why'd you do 9 minus 2 and not 2 minus 9? Say again? Okay. What would you get if you did 2 minus 9? Negative 7, you get a negative number, right? And then you have to remember, oh, can distance ever be negative? Can you run negative 7 miles? No. Okay. So you always want to think when you're subtracting as big minus small. Okay, so now let's find the distance between A and B. Let's find the number of hops between A and B. So 1, 2, 3, 4, 5, 6, 7. So what's the distance between A and B? What's the distance between A and B? 7. So what would we do if we were to subtract them? How would we subtract? Four minus negative 3. And what does 4 minus negative 3 give us? 7. What if you accidentally said negative 3 minus 4? What would we get? Negative 7. Okay. Do you guys remember ever hearing about the absolute value? Yes? No? Huh? Okay. So absolute value means that you're going to be looking at the positive value no matter what. So if we take the absolute value of negative 7, we're still going to end up with 7. So it doesn't matter. Whenever you're finding the distance, it's always going to be absolute value. Okay. How about number 2? Let's subtract. So what are we going to do when we subtract? how do we find the distance between C and D by subtracting? Derek. How do we find the distance between C and D by subtracting? -1 minus -8. Okay, what does -1 minus -8 give us? 7. Okay, so it's the same thing that you would get if you hop along this way. 1, 2, 3, 4, 5, 6, 7. So it doesn't matter if you're dealing with positive numbers or negative, positive or negative numbers. You're still going to look at the number of hops, the distance. Okay? Questions on that? What if we did -8 minus -1? What would we have gotten? We would have gotten -7. Is that okay? Yeah, because we're always going to be looking at the absolute value. So it would be 7. All right, so in numbers 1 and 2, I want you to take a minute and I want you to find the distance between each pair of points. On the graph. So the distance between L and K and the distance between K and J. All right, Sophia, what is the distance between L and K? 3. Okay, we go 1, 2, 3. So we have a distance of 3. How can we get 3 without hopping? What can we do? Without counting, how can we get 3? We can count or we can use subtraction. So we can say 4 minus 1 gives us 3. Because counting is fine right now, right? These are little numbers, but what if I gave you numbers that were 1,000? 2 and 1,000. Okay, then that's a lot of counting to do. All right, so how about between J and K? Jules, say, what's the distance between J and K?
4.
Okay, how'd you get that? You counted, okay, so 1, 2, 3, 4. So this side was 4. And then how can you get that by doing something other than, by not counting? Subtraction. So what would you subtract? 5 minus 1 would give you 4. Okay. So here we have number 3. We have the points L and J. So turn to your partner and talk about some things that are different, some differences between numbers 1 and 2 and number 3. Okay, what makes these two different than number 3? All right, so what are some differences? Anybody tell me what's different? What do numbers 1 and 2 have in common? Data, get her up. Can we count between L and J? We can't, okay? So numbers 1 and 2, we move left to right. And up and down, right? On number 3, how do you have to move? Do you know what that's called? We have to move on a diagonal. So the question is, can we count on the diagonal the same way that we count on when we're moving horizontal or vertical? Okay, so I have 2 squares here. Here's 1. Here's 2. Okay, now the diagonal of the square is this, right? I folded it down. Okay. Is the diagonal the same as a side? It's not, right? Because, I mean, this is a square. It's the same square. I'm not a magician. Okay. Same exact square. One on top of the other, right? Is that straight to the left? No. Okay. It's not. And so when we look at a square and we fold it on the diagonal, we see that it doesn't match up. They're not, the diagonal is not the same length as the side of your square. Is it longer or shorter? It's longer. Okay? So we need to find a way to find the length of the diagonal because we can't count it. And the way that we're going to do this is by creating a right triangle. Okay? So what we're going to do is we're going to connect our points on the diagonal. Okay. And then we're going to create a right triangle. We'll start at the bottom and we'll move to the right. And then we can move up. And here we have a right triangle. How long was this side? How long was this side on our triangle? 3. How long is this side? up and down, 4. So it's these two. We took these two and put them here. All right, so now that we have a right triangle, can we find the length or the distance between L and J? Can we find the distance between L and J? Yes, how? Huh? Not quite 4 plus 3. Close. What do we have here? What shape? What shape is this? It's a triangle. What kind of triangle? It's a special one. What kind of triangle is it? It's a right angle. It's a right triangle. Okay? So we have a right triangle. We made a right triangle. And then when you have a right triangle, how do you find the hypotenuse of the right triangle? A squared plus B squared equals C squared. So which side of this is C? The yellow, C. And then which of these is A and which is B? Doesn't matter. So A and B. Okay, so A squared, what's A? It could be, but based off of how I labeled it? 3. And what, so 3 squared plus, what's B? 4 squared equals C squared. What is 3 squared? 9. And 4 squared? 16. And what is 9 plus 16? So C squared is 25. Okay, and what do we do to figure out just what C is? Huh? Take the square root. Very good. So C is 5. So, what's the difference between the way we find the distance in numbers 1 and 2 and in number 3? How did we find the distance in 1 and 2? We counted. What else did we do? We counted and subtracted. When you have them on the diagonal, what do you have to do? When they're on the diagonal, we have to use the Pythagorean theorem. Okay. So, we need to talk about a couple of definitions. Okay. So, a segment is part of a line. It has a starting point and it has a stopping point. So if we have this line right here, we could call this line AB. When we take the ends off and we just look from A to B, this is called the segment. And when we talk about the length of a segment, we say AB equals whatever number, okay? So this is the length of a segment. Okay. And then you've got endpoints. The endpoints are where your segment starts and where your segment stops. Okay? So these are endpoints. So the steps that we went through to find the distance between each pair of points. What did we start doing? What did we do first? What did we do first when we found the distance between points L and J? What did we do first? Huh? I just didn't hear you. The what? Oh, connect them. Sorry. So we connected them how? What shape did we make? We drew a right triangle. So first we're going to find the distance by drawing a right triangle. After we drew the right triangle, what did we do? Let's go through it this way. So let's draw a right triangle. So we'll start at L. We'll make a right triangle with M. Okay. And you go along the grid line. So you're driving down like a road. Okay. So there's our right triangle. After you draw your right triangle, what do we do next? What do we do next? Carlos, what do we do next? We find the length of each leg. And we can do that by hops. 1, 2, 3, 4. What else can we do instead of counting hops? Subtract. So we can say 3 minus -1, and we would get 4. And then we hop up this way. 1, 2, 3. How can we do that other than hopping? How can we get 3 other than hopping? We subtracted here. What are we going to do here? We're going to subtract 4 minus 1, and we get 3. Okay, so then how do we find the length of our hypotenuse? How do we find the length of the hypotenuse? Jada, how do we find the length of the hypotenuse? We don't just add them. What do we use? We use the Pythagorean theorem to find the length of the hypotenuse. So in this case, what are we looking for? What side of our triangle are we looking for? What are we looking for? What side of this triangle do we need to find? The hypotenuse. And what letter do we make that? C. Good. Okay. And then what does the Pythagorean theorem say we need to do? A squared plus B squared equals C squared. So what is A? Sure. Doesn't matter which one? No. And what is B? It's going to be the other one. What is 4 squared? 16. And 3 squared? 9. And what is 16 plus 9? 25. Okay, so how do we find just C? What do? You take the square root of both sides. What's the square root of 25? 5. Okay. So I want you to go through, I want you to do number 2. And I want you to stop and put your pencil down when you get stuck. So start number 2 and put your pencil down when you get stuck. All right, so I saw a couple of different things. I saw some of you making your triangle on the top and some of you making your triangle on the bottom. Does it actually matter? No. So we're looking for the distance of the between H and I. Hi. Right? Hi. All right. So let's see. Let's go to the right and down. Okay, so how long was this side? 6. So we can get that from 2 minus -4. And then how long was this side? 1, 2, 3. So we get 2 minus -1, which will give you your 3. Okay, so how do we find the length of this third side? What do we do? Are you guys not sure how to answer it because you don't know how to say Pythagorean? Is that part of the problem? Okay, you can tell me a squared plus b squared equals c squared. Okay, that's a hard word that's just a hard word. Okay, so we know a squared plus b squared equals c squared. What's a? Sure. Could it have been 3? Yep. 6 squared plus, what are we going to make b? 3 squared. Oh, wow. Squared equals c squared. What is 6 squared? 36. And what's 3 squared? 9. So what's 36 plus 9? 45. So how do we get just C? What do we do? Square root. So C equals square root 45, 6.7. Good job, Dulce. Okay? Okay, so is that the reason why we're also having trouble getting this word out, right? Square root? We'll write it down here. There you go. Okay, so what is different? What's that? How do you put it in the calculator? I'll come over there and show you. Give me a second. Okay, so what's the difference between 1 and 2 and number 3? What's the difference between the first 2 and 3 and 4? There's no points. We have to do what? We have to plot them ourselves, right? We also didn't name them. Let's see. Let's name this. This one is C, and we'll name this one S. Okay, so let's talk about plotting these points for a second. So this is your X, and this is your Y. So you start at the center, and this says you move to positive 4 on the X, so positive 4 on the X, and up to a positive 3 in the Y direction, so up 3. So this is C. This one tells us we're going to move to negative 4 on the X and to positive 1 on the Y. So we start at the center, the origin, negative 4 on the X and up 1 on the Y. So there is S. Go ahead and find the distance between C and S. Go across the hall. You're going to start for just a little bit. Okay, and if you don't know something, just make us say oh, Anna. Use our time. All right, so we're looking for this segment, and we need to drive from S to C. Okay, how high is this side? 2. And how long is this side? 8. Okay, so how do we find our hypotenuse? So we can find that distance. What do you do? Perfect. Good job. A squared plus B squared equals C squared. All right, so, Jada, what's A? Huh? Does it matter which one is A? No. So let's call it 2. And if A is 2, then what's B? 8. So 2 squared plus 8 squared is C squared. So what is 2 squared? 4. And 8 squared? 64. Okay? So what is 64 plus 4? Oh no, my pen. 68. So, and how do we find just C? The square root. Very good. So we're going to take the square root of both sides. So the square root of 68, 8.2. Okay, we don't have time for the other two. Let's look at, for the other one like that, let's look at number 5. Okay, so number 5, we just have points. We don't have a graph. So what can you do? What are you going to do if you just have points and you don't have a graph? We could plot our points down still, right? So, this way. So, let's call this A and this B. And we're not going to plot them exactly because we don't have a graph, but -2, -8. Is going to be down here. And then 1, 3 is going to be up here. Now, are we going to find our points any different? Find our distances any different? This way. Already? Sure. Go ahead. Okay, so we're going to do it the same way. And you're still going to create your triangle. Hold on, Yanni, you're not supposed to go yet, are you? You don't go yet, do you?
Yeah.
Let me see. Let me see. Oh, I thought they had different times. There you go. Go ahead. Okay. So, how are we going to find the distances without counting? Because now it's not good to count because it's hard to see. We can figure out how the x's change. Here's an x and here's an x. And so we can subtract. We can say 1 minus -2. And what do you get? What's 1 minus -2? 3. And then we can use the y's to find the up and down. We have 3 and 8, -8. So we can say 3 minus negative 8. And what do we get? What's 3 minus negative 8? Huh? 11. And we're still looking. Did I say the wrong thing? For C. So do we do it any differently? It's going to be the same thing. So we're going to say A squared plus B squared equals C squared. So what is A? Does it matter? Nope. 3 or 11, either one. So 3 squared plus B is 11. 11 squared equals C squared. What is C squared? Blah, blah, blah. What is 3 squared? 9. And 11 squared? 121. So that gives us 130. Now, once we have C squared equals 130, how do we find C? What do we do? Take the square root. Good. So the square root $11.4. Now, when you take a quiz, you might get just the points, right? And you might not have a graph. But does that mean you can't draw a graph or ask for graph paper? You can do either one of those, okay? So I'm going to give you your homework.